Hello, everyone. Welcome to today's LinkedIn Live session. I'm Rubina Maharjan, and I'm the host for today's panel discussion here. Super excited to have you all joining us for the discussion that's sit right at the intersection of AI innovation, edge intelligence, and next generation FPGA technology. So, to guide us through this, we have a fantastic panel joining us. I would like to quickly introduce our panelists here. First, Laksh Joshi from Altera,
Everyone.
Matt Matt Campbell from Mauser, and Leon Bear from ONEWARE. So let's dive in. To start us off, I would like to start with Lux. And our first question is around, the growing demand of AI at the edge. So Lux, if you could, give some talking points around how do Agilex 3 FPGA delivers the right mix of compute density, power efficiency, and real-time performance to meet others' need, and how can our audience learn more about Agilex 3 to address this need?
Yeah, absolutely. It's a super exciting area right now as we work to build out this new realm of physical AI. It really means, from a silicon semiconductor standpoint of delivering intelligence at the edge, and that need has never been greater. Whether we're talking about industrial automation, robots, drones, these are quite distributed systems. They need to be able to sense, they need to be able to interpret, and then ultimately act autonomously around based on their environment. And so with FPGAs, we're trying to enable that AI augmentation. In many cases, there are systems that exist at the edge today that do a lot of these functions, but they need this greater intelligence. They need more control loops, and that's really where FPGAs excel. And along with that comes the realities that these environments have. These are products that need to be small form factors. They're typically mobile. They might need to be battery operated and therefore have a high power efficiency. The environments they operate in are also quite demanding. Maybe they have multiple camera sensors or many other sensor inputs, and they need that high performance and near instantaneous response time. So you have these kind of competing demands of small form factors and power efficient, but also do need to be performant and have rapid response to their stimulus. And so Agilex 3 as a product, as an FPGA, it really excels on these types of applications. It has performance with power efficiency. It has devices that have small densities, small form factors as small as 12 millimeters, and then also the embedded AI DSP tensor blocks, which allow our customers to implement AI compute along with the rest of their FPGA processing. So a very exciting product, I think, that we have created here for particularly really targeted well for these physical AI and embedded edge applications.
Really exciting to learn more about Azure X3, especially focused around Edge AI application and embedded applications. So, in the similar line, Matt, I would like you to throw some lights around how Mauser is supporting engineers who are exploring and trying to adopt Agile X3 based AI solution, particularly around developer kits, reference design, and supply availability aspects.
Absolutely. So at Mauser, one of our biggest priorities is enabling rapid prototyping. So we don't want waiting for parts to be a bottleneck in a design. So we ship very fast and we offer same day shipping where we can. And that's for both the Agilex 3 chips and the dev kits. So what we want to do is bring all of the great resources that Altera has created, like technical trainings and application notes, and we have all of that available on the product page on the microsite as well, so that when you're looking for the products, you have all the resources you need to get started quickly, because our philosophy is we want to just get the engineers the parts as quickly as possible so that they can start working and start developing and eventually bring their product to market. So for both chips and dev kits, we make it a priority to work closer with Altera to keep those things in stock so we can get them to you.
We appreciate the partnership, Matt. My next question, shifting gear a little bit, is to Leon. And Leon, I would like you to walk us through some few real-world AI workload examples that ONEWARE is currently implementing on Agilex 3, and also kind of elaborate on some of the use cases you see, developing around AI workloads.
Yeah, sure. So at OneWare, we built the software OneAI that automatically tailors AI models to the hardware and application of the user. So these AI models can be so efficient that they can easily run on FPGAs of all sizes with high performance and ultra low latency. In combination, Agilex 3 is ideal for many use cases that profit from its AI performance and compact form factor. So for example, one use case we see often is high-speed quality inspection in industrial environments, because this is ideal for FPGAs because of the efficient data pipelines that lead to extremely low interference latency, but also because of the high reliability when everything is integrated in one chip and the AI is running directly on the machine. But of course, also beyond industrial automation, the same advantages apply to many other fields we see a lot, like food processing, agriculture, drones, aerospace, basically everywhere where fast, efficient, and reliable edge AI is needed. So with OneAI and Agilex 3, you can easily build and deploy any type of vision AI tasks.
Truly, One AI plus Azure X3 is bringing AI everywhere. So this is a really exciting time for all of us. With
Yeah,
with that,
just jump in here real quick? I did want to point out I just think it's super cool, what OneWare has done to be able to build these kind of small models. I think there's this common perception or common expectation in the industry that to do real intelligence you need these very large models with many hundreds of thousands, millions, billions of parameters. But the reality is, there's a lot of insights that can be extracted even from small models, and especially when you need to run those in kind of these smaller form factors for these edge AI use cases, it gets super critical to be able to do that. And we don't have you oftentimes have a lot of power constraints in the edge. You don't have the ability to connect up to a nuclear power plant somewhere to power large data centers. And so I think having these small models really helps to be able to extend to use cases like predictive maintenance, anomaly detection, and many others that do require significant insights. If I recall right, I think Agilex 3 sits around just 5 TOPS. Five that's operations per second, 5 TOPS. And while it's small, it can help customers really deliver those powerful insights, and that's really enabled by the kind of model compression and model scale reduction that I think OneWare is doing. So I think that's a really really super cool and really important development for edge AI applications.
In fact, what we see as well is that these small models often even create more value to the customers because they are tailored to the problems of the customer than compared to these big AI models that then maybe um, automatically can write your email, for example. But if you have this really small, fast AI model, for example, in a quality control, this can be way more attractive for the company compared to these big AI models.
that's really cool. So, I think to solve some of the real world use cases, the solutions like these are really exciting especially for our developers. And my follow on question for both of you, Lux and Leon, is from a developer's perspective, how does Agile X3 software and development ecosystem look like? And you share some really cool use cases and examples and how we are solving problem. If you could kind of talk a little bit from developer perspective and share some guideline, that would be super cool.
Yeah, maybe I'll get started on that one. I think starting FPGA software is quite an important part of the developer experience. It's probably the most important part of the developer experience actually. And Altera offers really multiple tool chains for different types of developers. We start with Quartus as our premier development platform for all FPGA design. And then that also allows us to create offshoots, we have an embedded software tool chain that's really optimized for customers doing more of the ARM processing, within the FPGA. And then we also have other kind of higher level design tools that are available for customers. But then I think what's really cool for AI developers specifically is the FPGA AI suite. And so with FPGA AI suite, developers can choose, say, a pre-trained model from using OpenVINO, for example, or they can even bring their own using an industry standard framework such as PyTorch or TensorFlow. FPGA AI suite really allows developers to compile AI models into RTL code, and then that can then also generate the corresponding host CPU code, and this can all be done within the FPGA AI suite environment with a single button push, really. And then developers can then integrate that AI acceleration as if it was an IP, and they can integrate that just like any other IP core. And then they can act. And so now we've been able to really make the FPGA development environment accessible to many developers, maybe even those who don't have a huge amount of familiarity with FPGA design flows. Really, with FPGA Suite, AI developers can now access the FPGA development environment through a more familiar mechanism. And then along with that flow, that's where we can allow customers to do more of the model compression, take some of the larger teacher models, so to speak, and create a smaller student model that might be better suited for targets such as Agilex 3. And so this is where working with model developers and model optimizers like ONEWARE is another powerful way that we're making FPGAs more accessible to a broader set of developers.
And OneAI can then build directly on top of the existing FPGA AI suite, because here you can then export from OneAI for example, Onyx model or TensorFlow model you would usually create yourself, but it makes it much easier for developers to create their own AI models. But we also have the option to directly export our AI models as HDL, which then can even run on very small devices like Max 10. And in any case, with OneAI, the whole development flow is designed with the target hardware in mind from the very beginning. So you can, for example, just select how many FPS you want, and the whole workflow is visual, and you don't even need to code. So every developer, also without AI expertise, can create AI in minutes, often better than if you have experts that do manual development.
Thank you. My next question is for Matt. So as solutions like OneAI plus Agilex become available widely in market, if you could talk a little bit about what trends are you observing across different verticals from Mauser perspective?
Like Lux and Leon were talking about earlier, a lot of customers don't need a huge AI model to do a specific task. And so what we're seeing a lot of is what we're calling physical AI. And that's the idea where, contrast to what we think of AI a lot of the time is a giant model that lives in the cloud and you interact with it on your computer. Physical AI just takes a little slice of AI and puts it into the physical world. And so you have a device with sensors and controls that's actually taking in real-time data from its environment and then acting on that information that it receives. And so with FPGA based devices and the concept of physical AI, you have the ability to deploy models in very specific, very interesting use cases. So for like industrial automation, this could be a robot arm with very advanced machine vision, which was pretty cutting edge several years ago. And now it's very, very doable with something like the Agilex 3. And so there's a lot of applications like that where now you can make inferences on the edge, which not only keeps things fast, but keeps things secure too. So if you're in a medical or a security kind of environment, then your data stays with you at the edge rather than going into the cloud.
Yeah, security of data becomes more and more critical as we, develop more AI use cases. So, my next question, follow-on question for Lux is, how are we enabling our developers with Agilex 3 that helps strike the right balance between programmability, performance, power efficiency, and especially latency for critical edge AI workloads. And I think, all the, especially around security, how are we making sure, the solutions we are developing is secure?
Yeah, absolutely. I think, engineering is all about the trade-offs that you make to achieve your goals. There's no perfect system, so to speak, but there are, it is, there are certain architectural choices you might make that will be better or worse for the goal that you have in mind. And so, this is really where FPGAs really excel to provide engineers the opportunities to make the right trade-offs to achieve their system level goals. We have an FPGA that also has SoC capabilities with a dual ARM Core A55 processor integrated with the FPGA. And so this allows developers to partition their designs between a CPU and FPGA. Maybe they have certain things that are extremely latency sensitive. They need a more real-time response, and so they have a control loop that can be more in the FPGA fabric. Maybe there's other types of insight or processing that can be done in the SoC where they can take a little bit more latency, or maybe they don't need the same level of determinism. And so, those are ways where that's a trade-off that engineers can make using our products. We also have a soft processor. Maybe you need multiple soft processors to be able to achieve multiple processing streams. So that's with the Neos 5. It's a RISC-V based soft processor as well. So a lot of opportunities there to make optimizations based on your designs. We have a very wide density range spanning over from 25 KLEs all the way up to 135 K logic elements. And along with that, scales DSP and memory. So that all those resources really provide a lot of opportunities for customers to be able to optimize the utilization. Where you need to go off chip in memory, we have LPDDR4 memory controllers, whether that's for buffering data off chip or maybe storing some of the AI model parameters. Customers may also need to take advantage of partial reconfiguration if they want to be able to maybe load an alternative model without bringing their whole system down. They need to adapt to the environment. That's where partial reconfiguration can come into play. And then just a whole lot of I/O. Like I/O flexibility is really the hallmark of FPGAs, and especially in the physical AI world where you have many different interfaces, many different kinds of sensors across a lot of different standards. You need to be able to fuse those together through sensor fusion, and then use those data streams to be able to extract important insights. And so all those things are just super critical in the physical AI application. And then I think Matt mentioned security being an important part of the design phase. And so that's why we've integrated post-quantum cryptography secure boot into the Agilex 3 FPGA. Because these will, we see the rise of quantum computing, really accelerating in the pace of development, and so we want to make sure customers can be able to future-proof their designs as well, getting ready for any new threat vectors that might come out in the post-quantum world. So just a lot of different options that customers have available to them and designers have available to them to make those right trade-offs for their system architectures.
Definitely, that's a whole lot of options available for our developers and our customers who are working on building next AI workload and bringing solution to the market. So my next question is for Leon. As we look ahead, how do you see AI and FPGA architectures evolving over the next few years, particularly in terms of small form factors, higher bandwidth memory, and tighter CPU FPGA integration?
Yeah, so also in many use cases today, FPGA-based systems are already faster, more efficient, better integrated, and more reliable than other edge AI solutions. But the main challenge in the past was that foundation AI models kept getting larger, which makes FPGA AI development and optimization complex and time-consuming. But looking forward, with our platform OneAI and AI models and the FPGA implementations continue becoming smaller, more efficient, and more tightly integrated, then even if the tasks get more complex, the implementation will get easier and way faster. And new FPGAs like Agilex 3 will push this even further, with CPUs and FPGAs working closely together on a single chip, enabling extremely fast data processing and flexible workloads. And so here the FPGA does the heavy parallel AI compute, for example, while the CPU handles high-level control. And overall, I'm convinced that we'll see much more edge AI running directly on FPGAs, and also much complex systems integrated in one FPGA will come in the next years.
Thank you, Leon. My last question is for Lux and as well as Matt, both of you. And this is really I want to kind of again bring back for our engineers and for those who are new to FPGA world or new to building solutions around FPGA for AI. What advice do you have for them to get started with Agilex 3? And please feel free to share, recommend the tools, training, or open source reference design that's available in order to our engineers to ramp up the whole development process.
So Lux made a good point earlier about engineering trade-offs, and I think FPGAs are a great example of that because they're really good at what they do, but they require you to tell them exactly what you want them to do. So before you get started with an FPGA project, especially if you're coming from microcontrollers, understand that FPGAs are a different animal. And so Altera has a lot of great resources like the FPGA AI suite, but you really want to just fundamentally understand what's happening at the silicon level when you're using an FPGA, because that'll inform your understanding as you add those layers of abstraction back on that allow you to actually write your code and perform the functions you want to operate. So once you have that foundation, then you can start learning your way around Quartus, get familiar with VHDL, start mapping out exactly what sort of application you want to do, and then take on some sample projects. There's a lot you can choose from where you can just kind of plug and play and start figuring out how these things will actually work in the real world.
Yeah, those are great thoughts, Matt. All super relevant for this audience here. I would just also add that customers can get started with Quartus on Agilex 3 with no cost licenses. So that eliminates one of the barriers to adopting our software. Then, as you mentioned, we also provide a large number of example designs for customers to get started with. We have a broad set of training resources as well to help developers get up to speed on the software flows and the different tools that we have available for everything from design entry to debug. Lots of resources available there. And then, of course, once you're ready to start getting a design into physical hardware, we would recommend our customers to purchase a development kit. We have those for Agilex 3 available in stock with Mouser. So lots of they can get those very quickly. There's also a very large partner ecosystem of partners and SOM providers out there for Agilex 3 to develop a little bit more application specific dev kits and even production oriented SOM system on module application boards. So lots of resources out there for developers to get started with Agilex 3.
Well, with that, I would like to conclude today's panel discussion. And as Lux and Matt mentioned, there's a whole lot of resources available, like no cost software, the free training tools. Please do check out Altera.com website to get access to those resources, as well as Mouser.com to get your dev kits in your hands to get started with your FPGA AI projects. So with that, I would like to thank our speakers for a fantastic discussion today, and to everyone watching this live. And if you have any questions, any additional information you would like to get from us, please feel free to reach out to any of our panelists and partners here. Thank you again, and we will see you next time. And I would like to wrap up this session with our very cool demo video built by ONEWARE on Agilex 3.
Looking ahead, with our software OneAI, AI models and FPGAs will keep getting smaller and more integrated, tackling increasingly complex tasks. Thanks to also the new Agilex 3, high-speed systems will benefit from processor and FPGAs working more closely together. The FPGA handles the heavy parallel AI computations, while the CPU focuses on control and logic. So why do I believe AI models will become smaller, even though many people think AI models will get even larger and more generalized? At ONEWARE, we automate AI development to create efficient, ultra-fast and tailored AI models. For most applications, choosing a customized model is the smarter choice over a universal one. These optimized models also make the most of the FPGA's strength. As a result, the system achieves even higher performance with less resources. And to show what that looks like in practice, let me demonstrate it on the new Agilex 3. Here you can see an Agilex 3 development board running a simple number recognition model. Despite the compact form factor, it still has plenty of headroom. This small demo only uses 5% of logic elements, 3% of DSP blocks, and 18% of RAM by classifying images at over 600 FPS. So even much more complex applications could easily fit on the same chip. You can see that the numbers are correctly detected if I move the paper. And the AI runs fully on the FPGA. Only for demonstration we send the camera images to the FPGA with the laptop. Now let's see how quickly you can get your own AI running on the Agilex 3 in 30 seconds using OneAI. First, install the Agilex 3 device support in ONEWARE Studio. Then load your dataset, for example these handwritten digits. Select the Agilex 3 as your target, then define your target FPS, click on Start Training, and OneAI automatically finds, trains and optimizes the model for your FPGA. With the VHDL export, within seconds you get the corresponding HDL code ready to integrate into your FPGA. But I would recommend to just download OneAI now for free and see how easy it is to implement ultra-fast AI on Agilex 3 with your own applications.
We are Altera, accelerating innovators.